Okay, we're good to go? All right, terrific. Sorry about that, everyone. We had multiple things go wrong here, including the power, which I couldn't do very much about. But we're good to go finally. Welcome back to week 2. We will try to get these lectures starting smoothly and on time in the future, but we're here, and it's wonderful to see you. I really genuinely enjoy having these classes with you all there in person. It's fantastic, so thank you for being here. And for those of you who are on the live stream, thank you for tuning in. Now, we're going to do our second really important module on classes and objects today. This is incredibly important because in the Java language, objects are a really important idea. It's an object-oriented programming language. So classes and objects is what we're going to do now. And before we do that, we're going to do some admin. First of all, your student reps. We have some student reps, folks. I was overwhelmed by the number of applications we got, overwhelmed in a good way. We got a huge number of applications for student reps, and you can find them here on the course webpage at the moment. We've got Snow, we've got Ting, we've got Saeed, Navdeep, and Olivia are our class reps. If you're in the room, if you're one of those people and you're in the room, would you mind just standing up for a sec? Have we got one? Who? And anyone else? And I know we've got other people. And for example, Saeed over there on that list there, he is in Qatar and it's 5 o'clock in the morning right now. He will be our class rep, but he won't be here in the lectures because of the time of day, right? So I'm expecting the class reps to be here every Friday and to catch up with me after the lecture. And you all will have information on Piazza soon on how to reach out to them if you would like to talk to them, okay? So the goal of the class reps is if you have something you want to discuss or some issues you have with the class or even good things that you like about the class reps are there to hear that feedback. But a rule of thumb, always try to voice your concerns or things you like to the lecturer or the tutor involved before you take it to the class rep. It's just politeness and it's effective to do that. If you feel uncomfortable doing that, no worries, just go to your class rep. But if you can, it's always best whenever you give feedback to anyone on anything to go directly rather than indirectly. Okay, it's just that's a matter of good practice and politeness. Piazza is a great learning platform if it's used well, and we've had a load of activity on there, which is terrific. Don't forget that you can chip in and answer questions for other students, and tutors will give you a thumbs up if you're writing a great answer, which is good, so you get that sort of feedback. Labs, you will get a mark at the end of semester for engagement in the class, which is made up of a multitude of factors, including your lab participation, your engagement with quizzes on here, a whole stack of things, your engagement with Piazza, all these things combined to give you an itty-bitty, teeny-weeny mark for engagement. And if your exam mark is higher than the mark for engagement, the exam mark wins. It's an irredeemable mark. So some people stress a great deal about this. Don't stress about it. It's just a very loose measure of your engagement, and if you do well, you'll get a few marks there. If you don't, your exam will take precedence, okay? So this should not be a source of stress for you, and if you're engaged thoroughly with the class, you're going to do very well in this class, okay? This is a class where engagement really matters, just like learning a musical instrument, which I've told you before. Assignment 1 is due in a week from Monday, okay? So you've got about 10 days for that assignment. Don't forget to ask questions, also answer questions, but ask questions on Piazza if you have questions. And I think that's about it. A few notes about the assignment. The assignment is marked by the CI. You should now be familiar with the CI. You've used it in Lab 1, you've used it in Lab 2. When you do a commit and a push, you go to the CI and it'll tell you how you're going. That's how your assignment's marked. What that means is you need to be passing those tests on the CI to get good marks in the assignment. That's absolutely essential. So if the CI is saying it's all broken, then go to Piazza, go to your tutor, have a discussion about what the problem is, and try and work it through. But don't leave that till the last minute, obviously, okay? Because if it says it's all broken when the deadline comes, unfortunately, you're going to get a correspondingly poor mark. Remembering, though, that assignment 1 is redeemable. We're trying to get you bootstrapped with a fast start, so don't overly stress about assignment 1 because it is redeemable, but nonetheless, what we want you to do is to do that, and we want you to be looking at the CI. Why am I making you do this? Anyone know why I'm making you do this? Why do you think I'd be getting you to keep checking the CI? This is how software developers live and breathe, that's why. Okay, it's also a useful way to do assessments, and it's a good way for you guys to get feedback, so you know whether you're passing the test or not. You don't just think, oh, well, maybe my IntelliJ is passing the test. You know that the CI is passing the test for you. That's really good feedback for you, and you get it instantaneously. As soon as you do that push, a few moments later, you'll get the CI results. That's really helpful, right, from a learning point of view. However, if you go and work in industry, in any serious software job, they'll have CI. Every time you commit, they'll be tested by the CI. Everything you do will be tested by the CI. And if you mess the CI up, you need to get back and fix whatever you did, right? And so this is part of how we actually work in the professional software development world, right? So we're bringing software development practice into the classroom, okay? That's why we're doing it this way. Some of you are thinking, wow, this is a really strange way to mark assignments. It's actually mirroring what we do in the real world, okay? Any questions online or any questions in the room about the assignment or about the practicalities of the assignment? Yep, at the back there. Is there a style guide? No, there is not. It's a great question, though. Great question. Look, if you're worried about style, you'll see I try to follow just the standard Java Oracle style. Oracle, who sort of the nominal owners of Java, there is a style, and in IntelliJ, you can set that up, and by default, it'll give you a perfectly reasonable style. So if you follow the style there in terms of exactly where braces go and how things are laid out, that will work great. Beyond that, it's a matter of writing clear code, which is hard to enforce through a formal style guide. It's more about clarity of your writing, you know, whether you've got comments that make it obvious what's going on, you name variables in ways that make sense, and so forth and so on. That there's much more subjective. And you will get a small mark for that. I can't remember what the rubric is from assignment 1, but by the time you get to assignment 2, we do start giving marks for how clear your code is and so forth, all right? And the CI can't speak to that. The CI just says, yeah, you passed the test or you failed the test. One more thing, folks, really important. In a few weeks, maybe next week, I can't remember, we're going to start doing testing as part of the coursework. You've been doing testing since Lab 1 in terms of your exercises, but we're going to teach you about testing starting in about a week's time. And one of the first things you need to learn is that passing the test does not mean you've done it right. Okay? Please understand, if you pass a test, it does not mean you've got the right answer. All it means is you've passed the test. Okay, that's all it means, nothing more. Okay, so if the test doesn't cover all the cases, which it never will, then you can't be sure that you've got the right answer. All you can do is have high confidence that you haven't got the wrong answer. All right? Okay, so if you get a red light from the test, then you know you've got something wrong. If you get a green light, what you know is your test isn't knowingly wrong. Okay? And it's a subtle difference, and it's a very important one for you to learn. So if you say, hey, the test didn't consider this case, of course it didn't. The test can't cover all cases, and they never will. That's one of the limitations of testing, which you're going to learn in this course in about a week or so's time. Okay? Looks like we lost the mic. All right, we lost the mic. Can you hear me at the back if I project my voice? All right, the mic for the live stream is completely different, so they shouldn't have lost that, but I have no idea. Actually, I'll just get there's a spare mic. I'll try to remove it. Having a really bad technology day today. As you can see, I didn't do anything to make that thing die. It's probably a low battery or something. Friday, end of the week, the battery dies. All right. So we're going to mic 2 now. Got that? Yep. All right, good. All right, any other questions? That was a good question. Any other questions? Yep. The same as any normal assignment. If you do an assignment, you think you've got the right answer, ultimately your tutor will look at it and tell you if it's the right answer, okay? Or a good answer, okay? Right answer is there are many ways to solve a problem, right? So a test gives you a lot of confidence that it's probably right. But I'm just saying that the test doesn't say it is right, it just says we don't have any evidence that it's wrong. There's a difference between not having evidence that it's wrong and knowing that it's right. That's all I'm trying to say. Okay, so if you're passing the test, you're probably doing fine. But I just want you to remember that the test won't tell you that you're absolutely correct. It can only tell you when it knows that you're wrong. Yep. Yes. So both assignments are marked in a combination of CI and human. So the CI cuts through all the low-hanging fruit and tells the tutor that, oh yeah, you've passed all these things. Then the tutor goes and looks at it. They look at how you use Git. Are you using Git in a sensible way? You need to be using Git in a sensible way, folks. You need to be writing commits frequently with sensible commit notices. Okay, you get marked on that. And you need to be also writing good comments and your algorithms, particularly once you get to the HD marks. Like, is this a good algorithm? You're not going to get full marks unless you've done something superb. Okay, we do discriminate in this class. So if you do a good job is a 65 out of 100, right? That's a good job. That's a credit. That's great. Okay. If you do something exceptional, then you may get close to 100, right? But you have to do something extraordinary to get to that level. So I just want to set expectations right here, okay? So, and the human will be involved in that. You're not going to get 100 unless you're passing all the tests and the human's really impressed with the way you did it. Okay? Any other questions? And the human being your tutor. Okay, each assignment is marked by your tutor. All right, we need to plow on. Oh, yeah, I saw this cartoon. I thought it was pertinent to all of our classes, right? To everyone. I always like this sort of stuff. We don't know. There's so much stuff we don't know. And it's really, really good, like you just did. You ask questions. That's exactly what I want in this class. I want you to ask questions. There's no shame in not knowing something. The shame is when you think you know stuff and you really don't, right? Dunning-Kruger effect, right? What I like to see is people saying, hey, I don't understand what you're saying. Maybe it is obvious. Maybe you missed it. Maybe you didn't hear me right. Doesn't matter. Great to ask the question, and I'll go through it and explain it, okay? So always don't be afraid to ask questions. That's the point of that. All right, let's now get stuck into the substance of this class. We're going to talk about classes and objects, and I'm going to have to move fairly fast. We have another lecture in behind us, and we got screwed around with the power going off and whatnot. Okay, what are we talking about here? We're talking about locals. Remember when we looked at the Java Waterloo visualizer, we had the stack. Remember, we often saw things like I and X and so forth in the stack. We saw that in the last lecture. We have globals. That's a class variable. What's an example of a class variable? I've given you these analogies. They're a little bit tired now because I've said them so many times. What's an example of a class variable? Right? This is something that's associated with the type, not the specific instance. So think about the bicycle. This type of bicycle, there's some variable associated with this type of bicycle, and then there's going to be a variable associated with your particular bike. So what's an example? The class variable is the one associated with the type of bike. Yep. Size of wheel. This type of bike has a 700mm wheel. This type of bike has some other kind of wheel, right? So the size of wheel is a property of that type of bike, not a property of your particular version of the bike. Your particular version might have a speed or location or which gear it's currently in and so forth. They're attributes of your bike right now. The size of the wheel is an attribute of all of the bikes of that exact model, right? They all have the same size wheel if you're in that model, right? So that's the example of a class variable. And on the heap we have objects. So we have things that are local variables. They sit on the stack, and you see that on the Java Waterloo visualizer. We have globals, which are global values, which are an example. They're associated with classes, and I just gave you the example there. We had the example come from the person in the front row there about the size of the wheel. And then we have on the heap, what we call the heap is where objects go. It's called the heap for historical reasons, but that's where objects live. And you see that in the Java Waterloo visualizer. You see those little objects. Okay, so they're the three different kinds of variables. We have local variables, global variables, and heap variables. And we typically call the heap variables instance variables. That's the language we use, okay? Garbage collection. Who likes garbage collection? Oh, that's so disappointing. For those of you who don't know, ANU is known internationally for garbage collection. Isn't this exciting? And we're not talking about trucks and trash. We're talking about research into how you make garbage collection work. Right? My research group is really well known for garbage collection. You guys should be really excited about this, okay? So what is garbage collection though? Who knows what garbage collection is? Anyone know or why it's important? Yep, so someone just said there it's important because it collects all the stuff that you're not going to use anymore, which is fantastic. The alternative is for you to work out yourself when you finish using stuff, right? Imagine a really messy kitchen and lots of cooks going really, really fast and someone just chucking stuff in the dishwasher or putting stuff somewhere else and you're like, hey, where'd that thing go, right? You can't have something getting removed from underneath you if you're right in the middle of using it, right? That's not going to work. That's really bad, right? And it could cause a big problem, okay? You don't want to move stuff out of the way until you're finished with it. So you need to on the other hand, if no one moved anything out of the way, your kitchen would start piling up with stuff, right? So you need to keep recycling stuff, put them in the dishwasher, wash them, put them back on the shelf, take them off the shelf, start using them again, like this, okay? And in a busy kitchen, you might actually have people who are running around doing this all the time, right? Now, the alternative is for you to do everything manually, which is actually labor intensive, and it's actually easy to get it wrong in a computer because you've got to know when you no longer need this thing. Now, that's really simple with our 5-line programs that we've been using so far in class, but when you've got 2 million lines of code, knowing that no one else needs this thing is actually incredibly hard to get right. And guess what? Getting that wrong is one of the largest, is actually the single largest source of software security errors. Okay, that's why we have garbage collection. So a garbage collector automatically figures out what is no longer needed and then gets it ready to be reused. The memory can be reused. That's what garbage collectors are. You really don't need to know that much about it. I just like talking about it because it's my research field. So, and you can go read about it on my webpage, or you can talk to, there are ANU undergrads already, just anecdote for you all, to get you all excited, because I'd like to see you all excited. ANU undergrads, including one of my recent ones, are working with things like the garbage collector in V8. V8 is inside the Chrome browser. ANU undergrads have committed code and are working on that very garbage collector, which is running in all of your browsers. Okay, ANU undergrads. So we are really engaged with this. We do, and also with OpenJDK, which is the Java that you're using. We're working with that as well. Okay, so there's a lot of really cool work going on here, and undergrads are absolutely key to it. And I actually recruit from this class, just by the way. Almost everyone in my lab has done this class. All right, this is really important, and this is really important. This is really important in our language, and someone actually asked this question, I think, on Piazza. I just glanced at it because I was between meetings, but I saw someone ask, I think, about this. This is the way we talk about ourselves when we're in the context of a particular object. We're in a context of a particular object, okay? Now, Java does something sneaky. When you call a method, it just has the parameters, but doesn't say what method it's called on. So if I've got a person, remember we had the person, we had Fred and Mary, I think, and if I say set age, say Mary.setAge 20, right? That's an example I did in the last lecture. Okay, that says take the Mary object, call the method setAge, and give it the argument 20. That's what that says, right? Now, in other programming languages, when that happens, it actually passes to Mary the pointer to the object that's going to get changed, and the object is called this object. And you say this dot age equals 20. So you explicitly refer to it. That involves more text, more code, and so Java gets rid of that, shortcuts that, and you just say age equals 20 instead of saying this dot age equals 20. But sometimes you need to disambiguate, and you already saw me do that a few times in class, and in those cases, to disambiguate, if there's two things both called age, or two things both called x, or two things both called I, if I say this.x, I mean the x that's part of this object, the object that I'm currently in the method of, okay? Can anyone think of an example where we've used this in class already? Yep. Perfect. For the coordinates in the lab, when you wrote the constructor, right? You wrote a constructor in the lab this last week. You used this, okay, to say, someone's given me an x, but I mean this is x, the x that's associated with the object I'm initializing right now. So I say this.x equals the x I got given, right? That's exactly, no, in fact, I think that is by far and away the most common case where we use the this word. All right, also you can call other constructors by referring to this. It's a way of saying me, this object I'm talking about right here. Access control, I've talked to you about this a lot. The general model is what? We contain things. We don't make things more public than we need to, not because we're secretive, just because it hides complexity. And software is monumentally complex. You saw the craziness that I had at the start of the lecture, and I bet some of that stuff was related to software, okay? And software failures. Software is very, very complicated. It fails in strange and mysterious ways that are almost organic. In fact, my Bluetooth driver failed on the laptop at the start for reasons that are completely unknown to me, and the only way I could solve it was by rebooting the laptop, okay? Supposedly a reliable operating system. Those sort of things happen because of complexity. Very, very, very complex software, and things go wrong. All right, we hide complexity in languages by using different mechanisms, and in Java we do it this way, and we try to keep things as private as possible to contain complexity. Keep your mess to yourself. That's the message, right? Keep your mess to yourself so other people aren't exposed to it. It's not necessarily mess, but we just don't want to know the details. Too much information. We don't want to know the details, okay? Just tell us what you're offering, not exactly how you did it. So that's the mental model, and here we have different levels here, public being the most public, and private being the most private, and then there's a default, which is when you have no modifier in front. We try to use private when we can, okay? Class and instance members, I've told you many times now about class and instance members. Hopefully the message is getting through, okay? The class member, if I have a class called bike, then the class member is the attribute that's for all things of this type. And the example we had a few moments ago was the wheel size. So I have an integer field, which is the wheel size for this bike. That's the class variable. All bikes have the same wheel size if they're of this type. All bikes of this type have the same wheel size. We have a variable at the top that says bikes of this type have wheel size of 700. Done. Okay. Then we have things that are associated with the instance. This bike's location in, north, south, east, west, latitude, longitude coordinates is right here. It's an attribute of this bike or that bike or the other bike. They all have different locations slightly. They can't be in exactly the same place. And the same thing with methods. We can have a method on a class. The method on the class could be something like, give me the URL for the warranty information. That's the example I used before. That's a method on the class. Or it could be, tell me what wheel size it is. That's a method on the class. That's a property of the class, a property of the bike type. Okay? Or it can be a method on the instance would be, where is this bike right now? Okay, and it would return the location of this bike right now. And initializers, you all know that we can initialize through a constructor. If you did lab 2, hopefully everyone here is done lab 2. If you did lab 2, you would have written constructors for the coordinate. Right? You wrote the constructors for the coordinate. And we can also write constructors for the class. So we can establish things for the class. When someone initializes the class, the first time it's used, we can set stuff up for that as well. If we don't do that, what do we get? Does anyone remember in Java? If we don't set stuff in the object, what do we get? By analogy, the same thing's true in the class. Anyone remember what happens if we don't explicitly set stuff in the object? It gets its default value. Right? If I make an object and I don't call a constructor, it gets the default value. What's the default value for age? We just saw that in the last lecture. When we created the person, we didn't set the age. What happened to their age? Yep, it was 0. And for a Boolean, does anyone know what the default value is for a Boolean? It's false, and so forth. There's a whole lot of default values. So everything gets a default value unless you initialize it. But you can initialize it. That's what constructors are for. And the same, you can do the same thing for a class. You can have a static, what's called a static initializer, which initializes the class. All right, we have a thing called an enum type. Now, I'm mentioning this here. It's a little bit different to the other stuff in the lecture so far, but I'm mentioning it here because it is relevant to the assignment. And well, I don't think you actually have to use it much in the assignment. I don't think there's actually any tasks that involve this, but if you poke around, you'll see it in the assignment. And these are really cool things. This is a way of defining something which has a fixed range of values that are non-changing. Classic examples, if you look this up in a textbook, would be days of the week, right? That's not going to change. Like, we're still going to have Monday through to Sunday, those 7 days of the week. They've got names which aren't changing anytime soon, right? And the same, there's always 7 of them. There's not suddenly 8 days in the week, right? That's something which has structure, which is useful to record. What's another simple one? You might have something like where the planets are. Again, that's not about to change. You could have an enum saying, Mercury, Venus, Earth, Mars, and so forth. And they won't change enough. If you go to the Oracle tutorial, that's the example they use. They use planets. There are things like this where you want a structure. And another one might be direction. You might have north, south, east, west, right? Cardinal points. Again, that's a fundamental idea. We get basic types with Java like true and false for the Boolean or an integer. This allows us to introduce other ones that have distinct values like days of the week, planets, or things like that, which are not changing. They're just things set in stone. Okay? And the other one we have here is grades. We're going to use grades in a moment when we do the example. So here's the mini quiz. Hopefully this thing will work. Let's see if we can make this work. Come on. And then once we've done this, we will cut to the coding. waiting for my laptop here. Okay, publish the poll. There it is. Okay, so you got the mini quiz up there. Let's cut to code now and see if we can get through this lecture, as much of this lecture as I would like, before we run out of time. And we can't run over time here. I don't tell me I do not have a keyboard. Today's a very sad day. Seems like nothing's working today. How can I not have a keyboard? Okay, we do. All right, so new Java class. We're going to call it O2. 02, that's what we do. Put a 0 in there. Did someone say something? Dot person. Right, there it is. Okay, and what I'm actually going to do, wow, this is really slow. Why is this so slow? Okay, what I'm going to do here is I'm going to, actually, come on. I'm going to take things from the last week's lecture. There it is. I'm going to pinch all that. I could have just copied it over, which is what I actually should have done. But we're just going to cut and paste because we're in a rush and we're being lazy. Paste, maybe. There it is. Okay. All right. So I just stole all that code from last lecture. Oh, and look, it went and did this. We just want to get rid of that. It's realized it's trying to use the other person. Notice how it fully named that as being the one from lecture 1. We're just going to do that now. And we're going to do this. It thinks we want to refer to the person type in the other package, which is the object1 package. Okay, there we are, folks, and we can run this, and you saw this at the end of last lecture. Let's run it. There it is. Yep. Oh, switch the scene. Thank you, sorry. All these technology failures are getting me rattled. There it is, and we're running it now. You can see down the bottom here. Building, and there we have a result. Okay, you saw all that in the last lecture. Now what we're going to do is add some stuff. We're going to mess around with this a bit more and do some more interesting things. So the first thing we're going to do is we're going to talk about inheritance. I've talked to you about inheritance for a little while now. Okay, what were the examples I gave you? Can anyone remember an example I gave you? What's the most general thing what's the word we use for generality in English? We use the word thing, right? What do we use in Java? Can anyone remember? At the back there? Object, Java lang object. Yeah, exactly. Right, Java lang object is the most general thing. And we can make things more and more specific. Can anyone think of something more specific than a person? In the context of the university? Yep. Perfect. Student. Yep, exactly. So let's make ourselves a student here. And what we're going to do, what's the relationship in Java between a student and a person? Yep. Yeah, so the student is a subclass of the person, okay? So it's more specific than a person. But it has the same attributes as a person. It's still got an age and a name, but we're going to give them more attributes than that, okay? So what attribute do you think we should add to an ANU student? What, apart from their name and the age, which every person has, what does an ANU student have? Yep. Yeah, UID. Okay, so let's do that. Let's make ourselves a student here, and we'll say new Java class student. Can anyone remember in Java how I, oops, I must have pressed back, oh there it is. Can anyone remember how I specify, what the keyword is for specifying the inheritance relationship, saying that the student is a type of person? How do I say that? Anyone remember in Java? Yep. Not quite. Implements is for interfaces. Great suggestion. Anyone else? Yep. Oh, yep. Extends. Perfect. Yep. So we say extends. So the way we do it is we say student extends. Extends. You just have to type right. Student extends person. Oops. Okay, and there we go. And now, what's happened, folks? Anyone see what's happened here? It's complaining about something, right? Can you see that? Can everyone see it? It's complaining. So what do you think it's complaining about? Anyone got any ideas? Yep. I have two person classes. That's true, but that's not the problem. let's have a look at what the problem is. How do we find out what the problem is? We go to here. Okay, create the constructor matching its superclass. We've got to have a constructor for this thing that matches up with its parent. So we go like this. And now we've got a student, we give a name and an age, and it will call the superclass with a name and an age. What other thing do you think we want in our constructor though? We're going to, down the front, the suggestion was we want a UID, which we'll call a string because it's got that special format. String UID. Okay, so we've got a UID as a field, and we make it private, remember, because we want to keep everything as private as we can. We do that. Now, when we create a student, we should specify the UID at the same time. So we do that, and we say string UID, like that, okay? And then in here, what do you think we should do in here? Can anyone guess, having just done that lab you did? This is the constructor. We're going to create a student. We're going, well, hang on, let me back up. Let me wind back. What do you think this is doing here? Can anyone guess what that's doing? Yep. Exactly, it's calling the constructor of the superclass, hence the word super there, okay? It's calling the constructor of the superclass, which is why it says super, okay? So we're calling that, and we're giving our parent class the name and the age. So now our name and age will be set by virtue of our parent, okay? Because we've asked our parent to do that for us. Okay, we could have actually just said age and name and set them here, but that's just duplicating code. Better just to palm it off to our parents. They could have done something more interesting, right? So we just say super, okay? Then what else would we want to do here? Yep. Yeah, that's right. So we want to say something like this. This dot UID equals UID. Meaning, set the UID that's part of this object, the word this, to be equal to the one that's being passed up here. Okay, so the UID of this object is equal to that. So now we've set ourselves up. Did someone ask something? No? And the other thing we can do is we can write a getter method which will get the UID. Notice the UID is private. If we wanted to get it, we could write a method here which is public. This is a common practice to expose just the information we want. String get UID. There we go. And IntelliJ is smart enough to realize that that's actually sometimes it fills it all in for you. Anyway, return UID like that. Okay, that'll allow someone to get our UID. And the other thing we can do is we can write a toString method. Remember, we wrote a toString method for the person when we wrote that code on Monday. We can write the same here, which will be slightly more specific, right? So we can say something like this. We can say we're going to return a string. We'll say public string. Oh, it was suggesting it for me already. String toString. See how it's already suggesting that? There we go. No, cancel. Okay. Wow, look at that. It did it for us. Okay, we don't want it quite like that, but that's interesting. So IntelliJ just did all this stuff for us. What we'll do instead is we'll just say return, and we'll get our parent class to print out the name of the person, the information. So we'll say super dot toString. So that's getting the toString method from our parent, which will say name and age, or whatever it was doing here. Let's have a look. There it is. It's going to return the name and the age, okay? And then we'll come back here, and we'll say toString, and then we'll add the extra information, and we'll say something like this. We'll say has UID, and then print out the UID, add the UID to the string. I keep saying print out, but it says string construction. Okay, so now we've written ourselves a class which is more special than person, and it's called student. And what we can do now is we can write ourselves another little class here, which we'll use for testing this thing here. We can do it. We can do it in here if we want. Oh, let me just write it in here. I'll write a new class here. Java class. We'll call it an inheritance. Inheritance, like that. And what we'll do is in that one there, we'll just add the file to git. Yep. We'll write ourselves, have I misspelled that? No, probably have. PSVM, write ourselves a main method. There's a main method, and we're just going to do the same sort of stuff we did in the main method down here. Let's just, for the minute, we'll just paste that in, and we're going to make this more interesting in a moment. Okay, there we go, like that. We can just say, now what we can do is we've made Fred as a person, we can make Mary as a student, okay? So, student, Mary, and we're going to say their age, like that, and then a UID. Right? Oops, that's a big UID. Like that. Okay? So that's a UID, and now we have a person, and we don't need to set age because I just provided it up here. So let's get rid of that, and look what happens. That's what happens when we run this. So what we should see is we've got two things. We've got a person called Fred and a student called Mary. Okay, Mary is more specifically described as a student. Now, those of you who are sharp-eyed may have noticed that I declared Mary to be a person. This is really interesting. This is what we call polymorphism. We're going to come to it later. We can declare Mary to be the specific thing that she is, or we can say Mary's some person. I don't know if she's a student or not. We'll see what happens. And it turns out when you create it, you're creating a student. So then you're saying actually Mary happens to be a person who is a student. Right? So that's called polymorphism, which is really interesting, and we'll discuss that more later, so don't stress if you're not following me here. So we could have just as easily have written this, and that's also correct. Okay, so slightly less general. So we can run this, and yep, question? No, you can't. You can't do that. So let's just try that. Right. Okay, have a look on the screen, and if you do that, you get a problem. Let's look at the error message. So this is the question I got: is what happens if you do that? And then we can try and force it to be that, but it won't work. You'll get a type error when you do that because you've got a type mismatch. Because what you're trying to do is you're going the wrong direction. You can declare something to be something general and make it something specific. That's okay, but you can't declare something to be something specific and make it general. That's not okay. Okay, so let's just put Fred back to being a person again. Okay, now what we're going to do is one more level of specificity, and we're going to make ourselves a file new person Java class here. This Java class is going to be COMP1110, 1110 student. There we are. We'll add that in, and we're going to add some stuff in here. What are we going to put in the COMP1110 student? Oh man, we're going to put a lot of stuff in here. We're going to give them all their grades. Okay, so we'll say private int assignment 1, assignment 2, and then the class engagement, and then the lab test. The lab test is in week 4, remember folks, and if you do your homework things, you will have covered all the stuff in there. Mid-semester exam, private int MSE, MSE, and then private int exam, the final exam. Okay, so there's all your assessments, and then we can create a student. We can say public the COMP1110 student constructor here, and then we can pass in all that stuff. We can pass in their name, string name, comma, int age, and then we can specify all these other things too. Int s1, int, oh man, keyboard. S2, what happened there? Int, I didn't type int. C, continue class engagement, int lab test, int MSE, int exam. Right, there we go. And we can then call the superclass, which is what? What's a superclass? It's a student, right? Oh, we haven't said that yet. We better say that, extends student. So COMP1110 is a more specialized version of a student. Student could be anywhere in ANU. COMP1110 student has these attributes. And we'll say super and pass the name, age, and what else was there? Oh, and the UID. We need the UID. I didn't add it in there, I should have. UID. Okay. And then we're going to pass the UID here, and that's going to do all the setup that we need for any student, and then we're going to do the stuff that's specific to a COMP1110 student, and we'll say this dot assignment 1 equals assignment 1, this dot assignment 2 equals assignment 2, this dot CE equals CE. And what we're doing here, remember folks, is we're saying these fields of the instance are equal to the parameters that were given to us in this constructor. This dot lab test equals lab test. This dot MSE equals MSE. This dot exam equals exam. All right, great. now what we need to do, let's write ourselves some quick functions. We're going to write some functions here, and we're going to say private. We're going to write a redemption thing. You guys need to understand how redemption works in this class. Redeem. Can anyone remember how redemption works? For anything that gets redemption, we take the higher of, the max of, the marks for that assessment versus the marks for the exam that you got in the exam. Okay? And so we'll take two arguments here. Is the mark, int out of, and then, so it was, say it was out of 5, then you have to scale the exam down to be a mark out of 5. Then we just say return math dot, max of the mark that you got, say for the assignment 1, and then out of times exam divided by 100. Okay? So that is, we'll take the higher of your exam mark or whatever you got for that thing, like assignment 1. And then what we're going to do, one more thing here, let's find the final mark for the class. We can make that one public. Int mark, and then we'll say return, we're going to return the mark, which is going to be this, return, the assignment 1's redeemable, right? Redeem S1, comma, exam. It's out of 5, right? And then plus redeem, no, assignment 2 is not redeemable. S2 plus redeem continuous assessment, CE, comma, 5, it's out of 5, right? Plus, what else we got here? Lab test is also redeemable, redeem, lab test, and it's also out of 5. Plus the mid-semester exam, which I think is also redeemable, which I can't remember what it's out of, I'll just say it's out of 10. MSE, 10. By the way, this is not the curriculum, folks, so if there's a mistake here, the curriculum still stands. And then, what else have I got here? Just the final exam, I guess, plus the exam, divided by 2, because the exam's out of 50. All right? So that's our final mark for the class. And then finally, what we can do is we can say, write a toString method, so we say public, string to string. No, we don't want that. It's too clever for us. Trying to do too much stuff. String to string, like that. And we're going to produce a string which says what we want for the student. Return, and then we'll say super.toString, and we'll say so that will say the name of the person and their UID, and then we'll say that what the mark they got. So we'll say plus with mark of, and then we'll add the mark. Now I've got to finish up because our next class is about to start. And we'll, what I'll do here is I'll create this person here, and where are we? We'll make Fred be a COMP1110 student in the inheritance thing here. I'll comment that out, and we'll say Fred, COMP1110 student, Fred equals new COMP1110 student, and we'll give them the various marks. We'll say their name and their age, Fred, comma 19, comma and then their grades, and I'm making this stuff up because I just can't even remember what they are. What's assignment 2? So give them 20, continuous assessment, give them 3, and then the next one is the lab test, give them 4, and then the mid-semester exam out of what I think it's out of 10, give them that, and then the final exam will give them a mark of 75, and then that should do it, and we'll run that, and we'll stop at that point. Actually, we'll do our bio, which is very, very fast and important, because I'm going to introduce to you bugs. Here we are. Great. And so we've got a mark. Their total mark turned out to be 75. That's not because their exam was 75. That's just because that's how it came out. Give them a different exam mark, and you should see that it will change accordingly. And there we are. Great. And now let's very, very quickly finish this and let our next class up. Grace Hopper. Grace Hopper is another one of the heroes of computer science. She helped develop the first programming language and the first compiler. She helped develop the language COBOL. And as a fun side fact, she helped turn the word Bugs, that's her notebook where she found a moth in a relay in her electronic computer and says that there's a bug in the machine. And to this very day, we use the word bug. Have a great weekend, folks. Thank you for being here, and thank you for being online.